All right, we are making excellent progress. Here's where game theory comes into the picture. Game theory is the study of rational decision-making situations where the choices made by one party can impact all parties involved. The theory researches different scenarios of cooperation or conflict among the various parties. Its main applications are in economics, political science, and psychology, as well as in logic and computer science. Sounds exciting, doesn't it? Let's see how it applies to Bitcoin's decentralized consensus. First, we need to consider that Bitcoin mining is a capital-intensive business. This means that miners need to make a large capital investment in expensive computer hardware, also known as mining rigs. Bitcoin mining is so industrialized nowadays that most of the hash power comes from large data centers known as mining pools. Besides capital expenses in physical hardware, a mining operation incurs significant operating expenses. Such expenses include electricity for running the computers and for cooling them off. The intensive hash calculations done by the mining chips generate a lot of heat, so chips need to be cooled down continuously to keep working properly. Remember that Bitcoin is a global transaction network that runs 24/7, so mining computers run proof-of-work calculations non-stop. On top of that, there are property expenses for the physical location where miners have installed their computers, internet service fees, maintenance expenses, and other costs. All these investments and expenses are effectively put at stake by the miners and are a huge economic incentive for them to act according to the Bitcoin protocol. This system design effectively guarantees the security of the decentralized consensus mechanism and the integrity of the blockchain. You may wonder why that is such a solid guarantee that the Bitcoin system will work properly. Bitcoin mining is a very competitive business. Miners compete based on their computer hash power to be the first to solve the proof-of-work puzzle, remember? They do this in order to collect the block reward for adding new blocks to the chain. This process is so competitive that at present it's considered to be profitable only at places with very cheap electricity. A naturally cold climate is a great advantage too. If a miner doesn't follow the protocol when mining a new block, the block will not be accepted as valid by the other nodes on the network. This means no block rewards and substantial economic losses for the delinquent miner. Therefore, the best course of action for each miner is to follow the rules and cooperate. This seems like a brilliant application of game theory to solve a complex problem and align the interests of network participants, right? In our next lesson, we'll examine some scenarios of how a miner could potentially misbehave and what would happen in such cases. Thanks for watching.